In this video, we will see dry run of the code. Now let's quickly check the dry run of this code. So here we have this as an array, right? What are the total number of elements? So we check 3, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's 14, I guess. Okay, it's 4, 4, and it's 40. So now let's see. Okay, n is 40. And let's start by iterating. So first of I will do nums equals to nums dot sort. So instead of array, let's see that this is my nums array. I will sort it. So if I sort it, what will be my array? 0, 1, 1, then 7, 8, 8, 9, 10, 96, 97, 99, 0, 1. This will be my array. Let me mention the index 0, 1, 3, 5, 7, 9, 10. Okay. So here what I will do, I will take all these elements. So it is it is array I minus, and let's take last smaller. Here we will take the count. So count is starting with 0. Count is starting with 0. And max is starting with 0. So like max will be also starting with 0. This is done. This is done. This is done. Last smaller will be minus n. So this will be minus infinity. Okay. Now I will start from 0 to nums length. So suppose this is my I is here. The nums of I equals to last smaller. If 0 is last smaller, no. What I will do, I will continue. No, like this is not equals to. So 0 is not equals to minus infinity. So I won't come here. Okay. I'll come here. Nums of I minus 1. 0 minus 1. So I get 0. Array of I minus 0 minus 1. That will be minus 1. Nums of I minus 1 minus 1. Is it equals to last smaller? Last smaller is minus infinity. No, it is not equal. Will come here. Okay. Is nums of I. What is nums of I? 0. Nums of I only. 0. Is it equal? Not equals to last smaller. Minus infinity के equal नहीं है, right? Not equals. What I will do? Yes, it is not equal to. I will update the count to 1, and I will say last smaller will be my element, that is 0. Okay. And what I will do to this condition, I will find that max will be 1. Alright, count max. Let's move. I will be at 1. I will calculate. Is nums of I equals to last smaller? Is 1 is equals to last smaller? No. Alright. So what I will do? I will come to the next condition. Nums of I minus 1 minus 1 minus 1, that is 0. Is this is equals to last smaller? Yes, 0. Nums of array of I. Instead of array of I, you can simply say this is nums. Nums of I minus 1 is equals to last smaller. Yes, it is equal. Right, both are equal. Update the count will be 2. Last smaller will be nums of I. What is nums of I? That is 1. I will move further. Now I will be at 2. Now I will check if nums of I equals to last smaller. 1 is equals to last smaller. Yes, it is. Simply move it. Continue. Right, again next. Is 2 is equal to last smaller? No, it is not. So I won't come under condition. Nums of I minus 1. 2 minus 1. So this 2 is done. 2 minus 1. That is 1. I will check. Is 2 minus 1. 1 is equals to last smaller? Yes, that is equal. So what I will do? I update the count. Count will be 3. Last smaller will be the element. It will be 2. Now I will point to 4. Okay. What is the element? 7. Right. Is 7 is equals to last smaller? Nums of I equals to last smaller? No, it is not. Okay, I will come here. Nums of I minus 1. 7 minus 1. 6 is equals to last smaller? No. I will come here. Update the count. So my count will be 1. Okay, it will start from 1. And last smaller will be nums of I, that is 7. Again I will move. Okay, I will be at 5. Here I will check.
What is nums of 5 equals to last smaller? Nums of 5, 8 is equals to last smaller? No. Then I will calculate 8 minus 1, 7. Is it equals to last smaller? Yes, it is. Update the count. Update the last smaller. It will be 8 now. Now again I will move here 6. So it's nums of 5 equals to last smaller. Nums of 5, 8 equals to last smaller. Yes, it is. Simply move it. Okay, so to 7. What is nums of 5 minus 1? 9 minus 1, 8. Is it equals to last smaller? Yes. Update the count. Update the last smaller. Okay. Now move it. Now again, let's check it. This is important. 96. Is 96 equals to last smaller? No. Is 96 minus 1 is equals to last smaller? That is also no. So I will come here and count will be now update to 1. Right. And my max is also updating, right? Remember 1, 2, 3. So the maximum got 3. Here that is 3. Okay. So it will update to 1. And last smaller will be your element, that is 96. Okay. And again you will move. We'll check. Okay. 97 minus 1. 97 minus 96 equals to last smaller. Yes. Update the count. Update the last smaller. Then this 10th element 98 is 98 minus 1, that is 97 equals to last smaller. Yes, it is. Update the count. Update this last smaller. 11th term 99. 99 minus 1, that is 98 equals to last smaller. Yes, it is. So update the count. Update the last smaller. So it will be 99. If I update it max, it will be 4. Now I will come to 12. That is 100. Okay. 100 minus 1, 99. Is it equals to last smaller? Yes, it is. Update the count. Update the last smaller. Now there will be one more element, right? I am writing it here. Okay. I will be at 13. Okay. What is the element? That is 101 minus 1. 100. Is it equals to last smaller? Yes, it is. So what you will do? You will update the count. You will update the last smaller. That is 101. And that's it. That's the end of the loop. And the maximum count here you are getting 6. Okay. And that will be updated to 6. This will be your answer. Okay. So this is the dry run of approach 2. Now let's see the dry run of approach 3. Now let's see. Let me quickly write the indexes here. 0, 1, 2, 3, 4, 5, 6, 8, 10. This will be my value. So let's execute. If nums of dot length is equals to 0, simply return 0. So it is not equal to 0. I will come here. I will start from 0 to num dot length. Object of nums of I is undefined. Yes, 0 is undefined. Define it. So I will define 0 with the value of 1. Okay. Then I will come to 2. This 2 is defined. No, it is not defined. I will define it. Then again I will come. Is it defined? No, it is not defined. I will define with the value of 1. Then is 1 is defined? No. I will define with the value. Then is 8 is defined? Yes. So I will come under else condition and I will update the frequency. So I will update the frequency to 2. Now, is 1 is defined? Yes. I will come under else condition. I will update the frequency to 2. Okay. Now I will check 7. Right. So is 7 is defined? No, it is not defined. I will update the frequency with 1. Is 9 is defined? No, it is not defined. I will update the frequency. Then I will check 96 defined. No, not defined. Update the frequency with 1. Then I will check 97. Is it defined? No. Update the frequency with 1. 99. Update the frequency with 1. 98. Update, not 98. 100. I will define with 100 with 1. Then 101 with 1. 198. Okay. Now let's see. Now for key in object. So I will start from these keys, right? These keys in object. I will take the count. Okay.
I will check if object of key minus 0 minus 1 is present. Now let's see what I'm checking. Key minus 1 is not equals to undefined. Not equals to undefined, that means defined. If key minus 1, 0 minus 1, is it defined? So this is not defined, right? 0 minus 1. Let me mention it here. Is key minus 0 minus 1. Is it defined minus 1? No. Right. This is not a true condition. So I will come and I will check is object of key is undefined, not equals to undefined. That means it is defined. Okay, that is present. If 0 is present, yes, this is present. So I will update the right. So my key will be okay. So key was 0. I will update the key to 1. Okay, and update the count to 1. Now I will check again. Object of key is defined. 1 is defined. Yes, it is defined. I will update the key to 2. I will update the count to 2. Now I will check is my next element, that's key 2 is defined. Yes, it is defined. So what I will do, I will update the key to 3. I will update the count to 3. Now I will check is 3 is defined. 3 is defined. 3 is not defined. So I will check what is this count is greater than max. Yes. So suppose I initialize my max also here. Like here I have not mentioned, but max will be there. If max is greater than count, this count is greater than max. Yes, it is. So I will update the max with. Okay. Now after this, again we will start from right. I will take the next element. I will check 2 and I will check key minus 2 minus 1, that is 1. Is 1 is present? Yes, it is present. It is present. So continue. Move it. I will check 8. 8 minus 1, that is 7. Present? Yes. Move it. 1. 1 minus 1. 1 minus 1, that is 0. Present? Move it. 7. 7 minus 1. 6. Present? No. I will come here. Okay. I will see. I will say that 7 is defined, right? So update the key. So now my key will be 7 plus 1, that is 8. Okay. Count will be again start from. So here you can see my count is started again 0. It will again move to 1. Now from here, is 8 is defined? Yes, 8 is defined. Again, what I will do? I will update 9. I will update the count to 2. Okay. Is 9 is defined? Yes, it is defined. Again, I will update the key to 10. And I will update the count. Now, is 10 is defined? No, 10 is not defined. So I will stop here. I will check is count is greater than what? No, it is not greater. It is equal. I won't update it. Okay. But again, I will start from 0. So count will again start from 0. Okay. And I will take where we done the 7 part. I will check 9. What is 9 minus 1? 8. Is 8 is present in the object? Yes, it is. Continue. Move it. Now we will come to 96. What is 96 minus 1? 95. This is defined. No. So can I say my 96 is the lowest element? Yes. I will check. 96 is present. Yes. I will update to 97 and I will update the count to. Now 97 is also present. I will update 98. I will update to count to. Now again equals to key plus 1. I will update to 99. I will update to count to 3. Now again 99 is also present. I will update the count to 100. Update the count to 4. Now 100 is also present. Update the count to 101. Update the count. And now 101 is also present. I will update the count to 102. I will update the count to 6. Now is 102 present? No, it is not. Right? I will check. Is my count is greater than maximum? Yes, it is. Update the maximum. Again, my count will start from 0. Count will start from 0. I will check. So this is done 96. I will check 97 minus 6. Then 97 minus 1, that is 96. Present, simply move it. 99 minus 1, 98. Present, move it. 100 minus 1, 100. Present, move it. You can see I'm just doing continuous statement again and 101 minus 1, 100. Present, move it. 98 minus 1, 97. Present, move it. That's the end of my key in the object, and the maximum answer we will get here, that is 6. This will be our answer. So again here, now let's quickly discuss the time complexity of both the approaches. So again here, the maximum time that is spending here, that is in sorting. So time complexity will be of big of n log n. Although the time spent will be here itself, right? It will be n, but again we will take the maximum, so it will be n log n, and no space complexity. That will be because we are not taking extra space. Now here, what will the time complexity? This loop will run for n times, right? This will also run for worst case n times, right? Again, all the cases that will run for n times, because you will check out all the keys. But this while loop, if I'm saying an extreme case, right? This will run nearly n times. Okay. So n plus for one of these specific cases, it will be run nearly n times. So the maximum it will go, that is nearly 2n. Okay. So 2n plus this will go into your 3n, right? 2n plus n, that is 3n. And again, that is big O of n, right? So the time complexity will be big O of n. You can ignore the constant. The space complexity will be, because you are taking an object, right? So space complexity will be big O of n and all the elements are equal. So this will be the time and space complexity. And this is how you can solve the very good problem long list sequence.